Thank you very much for the invitation. In my talk, I first would like to explain to you how the immune system works in 3 minutes. And then I would like to tell you about our hypothesis and then show you 2 experiments which are consistent with this idea. So, as Carla said, the immune system is here to fight microbes. And do I have the... Is it this one? No? So these are them. Those are bacteria, viruses, fungi, parasites, and those are us. And we can't see them because they are too small, but we have cells who can see them. And cells, of course, have no eyes, but the way how they see things is to bind. And in biology, seeing, recognizing means binding. So there's no long range. You have to do something directly. We have these white blood cells that are born in the bone marrow. And these white blood cells, they fight the microbes. Taken together, these lymphocytes, to be precise, they weigh about 1.5 kilograms, as much as the brain or the liver. And that's about 2% of our body. So we spend 2% on defense, as opposed to 6% of the US national defense. Now, Carla already said that the white cells, they have a way to recognize something that is not us, microbes. But microbes, they mutate. And so we want to anticipate everything, also structures that will appear in 100 years. So these white cells, special white cells, B lymphocytes, they make antibodies. And they make antibodies in a completely random way. So we are prepared to meet the universe. But because we are prepared to meet the universe also contains self. So our B lymphocytes, as they are born, they also react to ourselves, to our own structures. So the ones that react to self, they have to be taken out of the population. And because cells are born every day, this has to happen every day. So every day, there's the chance that we become autoreactive. Now, how are they taken out? Well, when they are born, the first thing they see before they are mature is self. So this is what takes them out. And once they are released to the so-called periphery, then the population doesn't contain any more antibodies to self. So how do we get possibly autoimmune? Well, what happens if a virus is actually not from the outside, but the virus is contained in ourselves? And now I have to tell you the difference between cars and people. A car has a plan which is outside of the car. But our plan, the DNA, is in our cells, in every single cell. We are composed of 10 to the 14 cells, a lot of cells. And every single cell has the full plan to make our cells. Now, we are made of cells, and cells are made of proteins and nucleic acids. But the nucleic acids, the DNA, encodes the protein. But as it turns out, only 2% of DNA encodes proteins. The other part of DNA encodes what previously was called junk. And in addition, almost half of it are so-called endogenous retroelements, and those are the old companions I'm talking about, because they have been there for millions and millions of years. So what are they? They are called retroelements or retroviruses. They are little snippets of DNA. And as I said, almost half of the DNA is composed of them. They replicate when the cells replicate together with genomic DNA, but they also replicate by themselves for some reason. And when they do, they make so-called RNA, and that makes new protein. And now suddenly there's something new, which we think is, from the outside, is a microbe, but in fact it's ourselves. And so this is a potential of how to become autoimmune. An important thing of these retroelements, retroviruses, is that there is this little piece is transcribed, but it's also back transcribed into DNA, and then the DNA can integrate itself. So in addition to have new stuff, you also have now new genetic information. And this is in fact one way how cancer is started. So here I show you a cell, a lymphocyte, and you can see that under certain conditions, these little spheres come out, and those are retroviruses. So people and in mice, if they cannot degrade retroelements, they get autoimmune disease. And now I'm talking about one specific autoimmune disease. It's the Aicardi-Goutieres syndrome, and similar to it, hereditary lupus. 2% of all lupus cases have a defect in an enzyme that cannot degrade retroelements. And as I said, this is hereditary. The rest, the 98% of lupus patients, is so-called spontaneous, where one doesn't know what the cause is. Now, one can look in mice that have the same defect, and these mice get inflammation of the heart. They make also antibodies to DNA, which is a hallmark of lupus. And this is the one data slide I'm going to show you. This is a so-called survival curve for mice with this defect. At the y-axis, this is survival, and on the x-axis, it is time. And so one can see here that the mice live until week 4, and at week 5, they start to die relentlessly. So we figured if retroelements are cause of this autoimmune disease, we should be able to cure it with antiretrovirals. And we took antiretrovirals that are taken by AIDS patients. And indeed, these mice, most of the mice, are now stable and free of autoimmune disease. So this is one case of so-called repurposing, which we have talked about. The antiretrovirals, this was Truvada and Viramune, that are, as I said, FDA-approved drugs. Now I'd like to come to the second experiment, and this is done in the so-called BW mouse. The B stands for black, the W stands for white, and if you mate them, you get a brown mouse. So this BW mouse recapitulates very well lupus disease in human patients. There is the 10 times higher prevalence of females over males that they have. They have anti-DNA antibodies. They get kidney disease. What they also have is they have lymphoma development, meaning cancer of the white blood cells, of the B lymphocytes. Now, in human patients, thankfully, the risk to get lymphoma is increased, but not nearly as much as in mice. In mice, these BW mice all get lymphoma if they don't die by glomerulonephritis, inflammation of the kidney. So in there, we wanted to find out what causes the lymphoma or the leukemia, the cancer of the white blood cell. And perhaps there is a common cause for the formation of leukemia and autoimmune disease, as we hypothesize. And we have a way to find new insertion sites into the DNA. As I told you, retroviruses, they can be transcribed, and then they go in somewhere else into the DNA. And we have a way to visualize that, and this is visualized by a band here. You see here the mother doesn't have it, the father doesn't have it, the tail of the BW mouse doesn't have it, but there is a new virus integration into DNA. And in a scientific experiment, one does so-called controls, meaning we want to show that here it's not that we forgot something to load. This shows that we have put the same amount of DNA into every lane here. So this shows that it is consistent that in BW mouse, in the BW mice, cancer is caused by these retroelements, and our hypothesis is, as for the TREX1 mice, that autoimmune disease is also caused by it. And finally, thank you, Lupus Research Institute and donors.